What we want today will be about the polar coordinates, but that is the review with the trigonometry related material. Before we get to the calculus aspects, so I want to let you know that there is the remediation part with trigonometry, polar coordinates. So if you go that website, then you will see a lot more details. But what I will do today will be a kind of summary of the polar coordinate and polar graphs, because we will do integration and we will figure out the area of the polar curves. Let's start with polar coordinate summary. Polar coordinate system uses the distance between the point and the origin and the angle formed by the line segment connecting the origin and the point and the x-axis, which is called polar axis. What is shown here is polar coordinate is embedded to the rectangular coordinate system. In polar coordinate, there is a pole. Pole is an origin. And polar axis is identical to the x-axis when we embed that into the rectangular coordinate system. Let's connect the pole and the given point. When we do that, we can think about the distance between this origin and the given point. Let's denote that with r. So r is a distance between pole and the point. Let's say that is P. Then this line segment will form an angle. And when we think about the angle in centered position, we measure the angle between the positive x-axis and that line segment. Let's denote that as theta. In polar coordinate system, that indicate the direction. When this happens, we denote it as r and theta. What you have to be careful here is r is the distance between pole and the point. However, r is an oriented distance, so r may be positive or negative. plot the points whose polar coordinate are given. The first problem is 1 and 5 pi over 4. When you see this information, the first one is r, oriented distance, and second component is theta. So what you will do when you have a problem will be you will identify the angle and then you go toward the angle direction or opposite of the angle direction with the given amount with r. So we will locate the angle first. This angle is 5 pi over 4. This is pi, and this is 4 pi over 4. So we go a little bit further. So obviously, 5 pi over 4 is located in the third quadrant. This is 5 pi over 4. And then finally, we have to plot the point. This is the distance from this origin and the point toward the angle direction. So we will plot the point here where the distance is 1. What you have to remember about plotting the polar coordinate will be, as I did, the first thing I did was to locate the angle. The second one is about plot the point. This part, you have to be careful. R is an oriented distance. So what I said was if R is greater than 0, then you would plot on the angle direction. If R is negative, then you have to plot opposite of the angle direction. The next problem will be very similar, but R will be negative. So point is -1 and 5 pi over 4. This is a polar axis. And we do the same thing to draw the angle 5 pi over 4. It was in the third quadrant. So we want to locate the angle by plotting the point either angle direction or opposite of the angle direction. In this case, minus is attached to the distance. That means opposite of angle direction. So that goes opposite. And then you go opposite, the distance is 1. Indeed, we go opposite, and so we put minus in front of 1. So this time angle or the point is in the first quadrant. Any question? Any confusion? All right. Other important highlight is in polar coordinate, the expression about the given point can be infinitely many. Representation of the point with polar coordinate is not unique. All of the following are the same points. In the following example. So we have 1, 5 pi over 4, and we have 1, 13 pi over 4, and we have 1 and minus 3 pi over 4. What you notice from the given coordinate is a distance from the origin are different, the same, but angles are different. The common characteristic of the angle is those are coterminal angles. So here, if we add 2 pi means we add 8 pi over 4. And then when we add them up, 5 plus 8 will make 13. So those are coterminal angles. And when we think about the relationship between this and this angle is obtained by subtracting 2 pi. So 2 pi is minus 8 pi over 4. So 5 minus 8 is negative 3. And so all of them are coterminal angles. Coterminal angle means their terminal sides are the same. So direction in the polar coordinate will be the same. But not only coterminal angle case, but also when we have minus 1 and pi over 4, and minus 1 and 9 pi over 4, and minus 1, minus 7 pi over 4. Those are all the same points. What's going on here is like this. As we saw, this is 5 pi over 4. And if we go opposite, then obviously this angle is pi over 4. So when the point is given as -1 and pi over 4, instead of going toward this direction, we will go the other direction. And so this one can be expressed as -1 and pi/4. So this can be perceived as r equals -1 when the angle is pi/4. On the other hand, if we just think about this direction directly, then that'll be 1 and 5 pi/4. So those two are the same, even though angles are different, but we are thinking about the different direction. So they are identical points. Other important point you have to remember is conversion between polar coordinates and Cartesian coordinates. We've been embedding the polar coordinate in the Cartesian coordinate. When that is embedded, positive x-axis was polar axis. Let's suppose that we have a point P, which is represented as r and theta in polar coordinate. And which is represented as x and y in Cartesian coordinates. So when we join the two points with a line segment, we can draw the right triangle. In Cartesian coordinate, this horizontal line segment is x and vertical line segment is y. And by using the Pythagorean formula, r can be formulated as r squared equals x squared plus y squared. If we use the polar, use the coordinate definition of the cosine of theta was x/r, and the sine of theta was y/r, and tangent of theta is y/x when x is not equal to 0. From here, we can say x equals r cosine of theta and y equals r sine of theta. What you have to remember in this page will be, of course, you already know r squared is x squared plus y squared, but maybe you might not be able to figure out this instantly. So remember, x equals r cosine of theta, y equals r sine of theta, tangent is y/x. By using the formula, we want to convert the given polar coordinate to Cartesian coordinate. Convert 2 and pi over 3 from polar to Cartesian coordinates. So 2 is r, and pi over 3 is theta, because that is a polar coordinate. So we will use the formula r equals x equals r cosine of theta. So r is 2 and cosine of theta is pi over 3. So we think about 30, 60, 90-degree triangle. This is pi over 3. This is opposite, and 1 is adjacent, and 2 is hypotenuse. So that becomes 2 times adjacent is 1, and the opposite hypotenuse is 2. So that is 1. Y equals r sine of theta. So that becomes r is 2. Sine of theta is pi over 3. So that is 2 times opposite, which is square root of 3 over hypotenuse, which is 2. So that becomes square root of 3. So the coordinate we are looking for will be 1 and square root of 3. Can I move on? The next problem is about representing 1 and negative 1 in terms of polar coordinates. This time x is 1 and y is negative 1. When we have this type of problem, what we will use will be r squared equals x squared plus y squared, because we have to figure out polar coordinate, and so the format will be r comma theta. And another formula we will use will be tangent of theta is y over x. So r squared equals x is 1 squared plus y is negative 1 squared, which is 2. So r is square root of 2. And from here, y is negative 1 and x is 1. So that is negative 1. And when we plot the point, that point is here, because x is positive and y is negative, and this is 1 and negative 1, right? From here, what you have to think about is the right triangle, which is 45, 45, 90-degree triangle. So what we know is tangent of pi over 4 equals 1 over 1, which is 1. So reference angle of theta equals pi over 4, because this is opposite and this is adjacent. And this is a negative value. And so we go this way, and the angle is minus pi over 4. So theta equals minus pi over 4. We will combine these two results, then we get square root of 2 and minus pi over 4. Polar curves. That is represented by the equation r equals f of theta. Sketch the polar curve. The first equation is really simple. It is given as r equals 2. On the right side, there is no theta related things. So what we have to do is interpretation by looking at the equation. So r is the distance between the point and the origin. So there is no theta here. So the meaning of the equation is the distance between the origin and the point in the graph will be uniformly 2 regardless of the angle. So that is just a circle whose radius is 2. So it looks like this. So the distance is always 2. In the second equation, we have theta equals 1. This time, distance doesn't matter, but angle is always 1. Here, 1 is a number, so that is not a degree measure, that is a radian measure. So that is approximately one third of pi, because pi is 3.14 and pi is 180 degree. And so it'll divide the upper half plane approximately 3 different regions. And so probably we can draw that radian angle here. But this is the radian angle, which is 1, theta equals 1. However, the meaning of this is the angle is always 1 regardless of the distance. So if we collect all the points here, then the distance will go from 0 to infinity. However, if there is a negative distance, then we have to go the other direction. So we have to extend the line to the opposite direction also. So in the first quadrant, the points are represented. The points will represent the point when r is greater than 0. And in the third quadrant, the points will represent the point when the distance is negative. The third one is R equals 2 cosine of theta. This time, this is a little bit ambiguous because what I told you was when you convert the polar coordinate to Cartesian coordinate, the formula you have to use will be this formula. So when we try to identify the formula, which may be useful for this case, that doesn't really work because we can see cosine, but we cannot see R cosine. So what we want to do is we want to multiply by R on both sides and see what happens. So we multiply R on both sides, then left side becomes R squared and right side will be 2R cosine of theta. Then we immediately notice that on the right side, that becomes 2 times R cosine theta was X, and R squared was X squared plus Y squared. So what we want to do is we want to identify this one as a circle. So we move 2x to the left, then we have x squared minus 2x plus y squared equals 0. We can do what we want to do by using the completing the square. In this particular case, the formula you have to think about is a minus b squared is a squared minus 2ab plus b squared. So we will add something in the middle to understand this one as something squared. So what we will add will be half of this 2 squared. We added this number, and so we have to do the same thing on the right side also. After you do that, what we notice here is this can be decomposed to this pattern. So that becomes x minus 1 squared plus y squared equals 1 squared. So in college algebra, you learned the general pattern of the equation of a circle. In this case, this is an equation of a circle with a center 1, 0, and radius equals 1. This one is radius. This one becomes 1, and nothing is added, so y center is a 0. So if we visualize the picture, then the center is at 1, 0, and the radius is 1. This is 1, 2, and so that is a circle like this. The next thing we want to go through is the pattern of the equations and pattern of the graph. I will not present anything of further details about that. what I suggested to you at the beginning of this class hour was you can refer to the video clips and lecture notes I already posted on the course website. That will explain all the details and you will find a lot more examples from there. The first pattern is equation of a horizontal cardioid. That is R equals A plus or minus A cosine of theta. When that happens, the graph looks like cardioid. This is a cosine involved cardioid, and so it is kind of placed horizontally. But if that is sine related cardioid, the cardioid will be placed like vertically. The pattern of the equation is R equals A plus or minus A sine of theta, and the graph looks like this, heart shape. When we say that is a cardioid, those two numbers are the same. If they are different, then it becomes Limassol. Which will have an inner loop. The other pattern of the equation will be equation of rows. The pattern of the equation is R equals A cosine of n theta when A is not equal to 0 and n is a natural number. Or R equals A sine of n theta. So when we say the given graph is a rows and the equations look like that, those will look like this. Or it can look like this. Did n decide the number of petals? Number of petals depends on n and also whether that is even or odd. If this number is n, the odd number, then number of petals is the same as n. So in this case, n equals 3. But if the number n is even, then the number of petals will double. So in this case, there are 4 petals. So we can say that in this case, n was 2. The last pattern of the equation we will do integration to figure out area will be equation of Limassol. The pattern of the equation is very similar to the cardioid, but the only differences will be A and B are different. And then that is Limassol. Depending on the equation, it can be horizontally located or vertically located. This sign will make the graph vertically located. It is very similar to heart shape, but there is a loop inside in the equation of in the graph of the Limassol. If that is related to a plus minus b cosine of theta, then again the similar cardioid, but there is an inner loop. Tomorrow, we will work on the area and length of the polar coordinates. And we will graph all of those explicitly before we evaluate with integration. And so if you forgot a lot of things which is related to the polar coordinates and polar graphs, then make sure that go to the course website and go through the trigonometry lecture note, and you can watch some of the video clips to understand it better. But what I'm lecturing today will not be in the exam range because we already finished the exam ranges material. So you have some time to digest all those things. And if you don't have time right now, and then probably it is much better to spend a lot more time to do well in the exam, because that will come on Monday. And also you will have spring break. And so you can make up if you don't go to travel. Do you have any question? All right, study hard and hopefully you will do better in the second exam, and see you tomorrow. Just a moment, just a moment. Yeah, here is the code.